Welcome to My Dreams Academy. So today we are going to discuss most awaited JEE Mains Shift 1 24th January today. So we are going to discuss we are going to deal inorganic chemistry where 7 questions came. So those 7 questions we are going to discuss for Shift 1. Okay, so first question they have given the coordination compound. So for this coordination compound they are asking to calculate what is that? Primary valency and secondary valency. So according to which theory we can calculate primary and secondary valency? So we have read it in coordination compound. What is that? Through Werner's theory. Through Werner's theory. So Werner's theory is going to tell you about primary valency and secondary valency. So this primary valency, what is the primary valency of a coordination compound? It is nothing but the oxidation state of central metal ion. So oxidation state of central metal ion. So what is the central metal ion in this coordination compound? Cobalt is the central metal ion. So how to find out oxidation state? Let's take its oxidation state as X plus what is the oxidation state of ammonia here? Ammonia is, since being a neutral molecule, so its oxidation state is what? 0. So how many ammonia molecules are 5? So 5 into 0 plus, so what is the chlorine's oxidation state? -1. So that's why we can write -1. And what is the oxidation state of 2 chlorine atoms? So it is also 2 into -1. 2 into -1 equals to 0. So how much we are going to get? X -1 minus 2 equal to 0. So X is equals to plus 3. X is equal to plus 3. So what is the primary valency of this cobalt? That is what? Plus 3. So what is the secondary valency? Secondary valency, according to Werner's theory, it is nothing but coordination number. It is nothing but coordination number. So if you could able to find out the coordination number, you can get what is that? Secondary valency. So what is the coordination number of this one? It is nothing but number of ligands. So coordination number, how will you find out? So number of ligands attached to the central metal atom into its denticity. What do you mean by denticity? So how many pair of electrons an anion is able to donate to central metal ion? So that is what called its denticity. So if you can see, if it could be able to donate 1 pair of electron, then it is called monodentate. If it is could able to donate 2 pairs of electrons, then it is called bidentate. So similarly, we can write number of ligands attached. How many ligands attached here? So 5 ammonia ligands and 1 chlorine ligand. So total how many ligands are attached? 6 ligands are attached. So 6 ligands. And what is their denticity? How many pair of electrons they can donate? Ammonia can donate only 1 pair of electron. Here chlorine is attached. Chlorine is also what? It can also donate 1 pair of electrons. So all are what? What kind of molecules are, what kind of ligands are attached? They're monodentate. That's why the denticity is 1. So finally, what is that? Coordination number. What is the secondary valency? Its coordination number, that is 6. So what is its primary valency? It is nothing but oxidation state of central metal atom, that is plus 3. So what is the answer here? So primary valency is plus 3 and secondary valency is plus 6. This is the answer for first question. So next we are going to discuss is second question. Here is given another compound. So its electronic configuration is given E to the power m and T to the power n. So here what they are asking to calculate the m plus n value, where n is what? Number of unpaired electrons. So in this case we have to understand, so we have to find out the oxidation state of this cobalt first of all. So in the oxidation state, how will you find out the oxidation state? X plus 4 into -1 for each chlorine, that is equal to, charge is given -2. So how much? X is equals to 4 into -4 goes to that side, plus 4 minus 2, it will be plus 2. So oxidation state of cobalt here is given, what is that? Plus 2. And when the oxidation state of this D block element is plus 2 and it is attached with the ligand is called, what is that? Chlorine. So then in this case we know that this chlorine is going to be what? This chlorine Cl minus is called as what? Weak filled ligand. So this is what? It is a weak filled ligand, and since it is weak filled ligand and it is attached with how many ligands here? 4 chlorine atoms. And what kind of complex it is going to form? It is going to form tetrahedral complex. So in this case of tetrahedral complex, So how to write their crystal filled system. So how to draw the crystal filled diagram for them, so that once we know that crystal filled diagram, so then we can easily calculate what is M and what is N. So in this case of tetrahedral complex, we generally know that in the case of octahedral complex, so these are what? D orbitals. These are what? E and T2 are what? D orbitals. But in the case of tetrahedral complex, since it is unsymmetric, tetrahedral is what? Unsymmetric. What is going to happen? In general octahedral complexes, what is going to happen? E is having more energy because it's unsymmetric. That's why we don't represent it as EZ or T2Z. So since it's unsymmetric, so we don't write gerades here. So that's why it is represented as E and T2. Only E and T2. In this case, what we are going to understand is these D orbitals are generally degenerate orbitals, but because of ligands are attacking to this central metal atom. So because of this repulsion, what is going to happen? There will be splitting of these d orbitals is going to take place and splitted into higher energy orbitals and lower energy orbitals. Initially their d orbitals are what? Similar energies, but because of ligands are coming and attacking to this anion, the central metal ion. So here what is going to happen? Here splitting of d orbitals takes place. So these degenerate orbitals are splitting into higher energy orbitals and lower energy orbitals. So which orbitals those are? Dx square minus y square and dz square having more energy because these orbitals lie on the axis, while in the case of dxy, dyz and dxz, they don't lie on the axis. So because of that reason, the ligands, when they are attacking on the axis, what is going to happen? Because of more repulsion, more energy is going to be produced. So because of that reason, EZ are called as what? EZ is having more energy and T2Z having less energy in general in octahedral complex. In the case of what is that? Tetrahedral complex, what is going to be unsymmetric and the ligands are approaching and attacking on what is that? dxy and dyz and dxz plane. Because of that reason, more repulsion will take place, so that the energy of what is going to happen? T2 will be more than E. The energy of T2 will be more than E. Here why we are not representing G also I have explained, but here the energies will be more for what? T2 than E. So here I will write in this case T2's energy is getting more than E. So because of that reason, the crystal filled diagram is going to be changed. So here we can see cobalt 2 plus is there. That means how many electrons are there? Cobalt generally is 27. So 2 electrons lost means 4s2. So what is that? It is what? 3d7. So 3d7 how will be represented? 1, 2, 3, 4, 5, 6, 7. This is what? 3d7. So in this case, how to do the crystal filled theory? We can apply here. So this is divided into, what is that? Since T2 is more energy, so E will be there. E means how many boxes? 2 boxes. While T2 will having what? 3 boxes. This is what T2, this is what E. So in this case, see these 2 unpaired electrons, they will remain as it is because they are not going to experience any repulsion here. So here it will be 1, 2, 3, 4 in this case. While these 3 will remain in T2. Since it is weak field ligand, so the difference between this delta T will be minimum. When delta T will be minimum, what is going to happen? So the electron can easily jump to what is that? T2, and they are going to form this complex. So in this case, what they are asking, E to the power m. E to the power m means in E, how many electrons are there? 4. That means E to the power, we can write here E to the power 4. And in T2, how many electrons are there? 1, 2, 3 unpaired electrons. 3 unpaired electrons. So T2, 3. So totally, what is that? M plus n value, how much? 4 plus 3. That is the answer will be 7. 4 plus 3, answer will be 7. So this is what the answer for this question. Next given, third question. In third question, what is given? Frequency to the power n is proportional to atomic number. What is given? Frequency to the power n is proportional to atomic number, that is Z is given. So we know that the graph between frequency and atomic number which is given by Moseley, in that case he has given the formula, what is that? Nu to root over of nu or root over of frequency is equals to A into Z minus B. A into Z minus B. So finally it is what? These are what constants here. Z is what? Atomic number. That means frequency is root over of frequency is directly proportional to Z. So here root over of frequency is given. Root over of frequency means what am I here? Root over of frequency means it is what? Nothing but root over is nothing but 1 by 2. Here it is a Z minus B. So that means frequency to the power 1 by 2, that is proportional to proportional. If you will remove the constants, it will is what? It will act as what? Proportional to what is that? Z only. Proportional to Z. So from this equation, what we can understand, the n value is nothing but 1 by 2. N value is 1 by 2. This is what the answer for third question. Next, fourth question we can see. In the fourth question, they have given the correct order of covalent character. That means no compound is purely ionic or covalent. So every ionic compound will have some covalent character. Who said? This is what? Fuzzen's rule. According to Fuzzen's, he said that every ionic compounds will contain some covalent character. So in this case, how will you identify? So those cations, so since ionic compounds will have cations and anions, so the size of anion should be smaller and size of the cation should be smaller. Size of the cation should be smaller and charge on the cation should be more, and the cation, if it is containing pseudo noble gas configuration, pseudo noble gas configuration means NS2, NP6, ND10. If they are containing this pseudo noble gas configuration, then they are going to will show more covalent character. If in the case of anion, those who having larger anions, the size of anion should be larger, and as well as the charge on the anion should be what? Should be more. Then they will show more covalent character. So in this case, we can compare between Kf and Ki, between potassium fluoride and potassium iodide, who will show more, what is that? Covalent character. In this case, so we have seen that cations are same for between Kf and Ki. So cations both are same. So we don't check cations. So we have to check only what is that? Anions. In this case of anions, first see the charge. So both are halogens, so their charge is -1. Same charge. So what you have to see? The size of anion. So to show more covalent character, the size of anion should be larger so that more polarization can happen. So in this case, what is going to happen between fluorine and iodine? What is going to happen? Who should show more covalent character? That means whose size is larger. So whose size is larger between fluorine and iodine? So iodine size is larger. So the size of anion, iodine is larger. That's why it will show more covalent character. So which is true? Which is true? Between Kf and Ki, the covalent character is true for A. Similarly, we can see for CuCl and NaCl, between CuCl and NaCl. So in the case of both are same anions. Both are having same anions. Now we have to see cations. In these cations, what is going to happen? The charges are also same, +1 and +1. But what you have to see, the electronic configuration. Here we don't see the size of the cation, but here we are going to see this electronic configuration. In the case of copper Cu+, what is the charge? +1. So Cu+, it is having what? Pseudo noble gas configuration. What is that? Pseudo noble gas configuration. What is the formula? Electronic 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 is not there. So it is what? 3d10, because one electron is gone from 4s1. So what is the electronic configuration? ns2, np6, nd10. It is what called pseudo noble gas configuration, PNGC, pseudo noble gas configuration. So those cation which is having pseudo noble gas configuration, they will show more polarizing power. When the cation will show more polarizing power, means what is going to happen? It will show more covalent character. So between CuCl and NaCl, who will show more covalent character? CuCl. That's why answer will be this. And between lithium fluoride and potassium fluoride, same, it will be having what? Same anions. Next we are going to check the cations. So for cations, what you have to see? Their size as well as charge. In the case of charge, both belongs to same group 1 element. So charge will be same, +1 and +1. But next we are going to see the size. So to show covalent character, the size of the cation should be smaller. Who is smaller size? Lithium is smaller size. So it will show more covalent character. So in this case, in the fourth question, what you have seen here, correct order of covalent character, who will show the covalent character, the orders? If you see A, B, C, all of them are right. So this is what the answer, A, B, C is the answer. So next we will see the spin only magnetic moment. So for which ion they have given spin only magnetic moment is 3.87 Bohr magneton. So to find out spin only magnetic moment, so how to find out this? This is equals to, the formula is n into n plus 2 Bohr magneton. So this is the formula where n is what? Number of unpaired electrons. Number of unpaired electrons. In the case of, if you see the number of unpaired electrons for each of them, we have to find out, and we have to put in this formula, and we have to compare with this value. So in the case of titanium Ti2 plus, so titanium atomic number is 22. So here it lost 2 electrons, means 4s2. The electron went from 4s2. So what is the outermost electronic configuration? 3d2. So in this 3d2, how many unpaired electrons are there? So here n is equals to 2. So n is equal to 2 means if you put here 2 into 2 plus 2 4, 4 2s are 8. So root over of 8. So root over of 8, it is not close to, what is that? It is close to 2.8 something. It is close to 2.8, not 3.87. Hope you're getting my point. So this is not the answer. In the case of vanadium, so it lost to a V2 plus. So that means 4s2, atomic number is 23. So it lost 2 electrons. That means that 2 electrons lost from 4s. So what is that? It is what? 3d3 is electronic configuration. Outermost electronic configuration 3d3. Here, how many unpaired electrons are there? 3 unpaired electrons. Since 3 unpaired electrons, so what is that formula here? Is equals to 3 into 3 plus 2. That means 5 3s are 15. So what is that? Root over of 15. Root over of 15 is close to, that means it is what? Root over of 16 is 4. So root over of 15 is close to, what is that? 3.8 something. So what is the value? 3.87 they are asking. So here itself the answer we are getting. What is the answer? V2 plus is the answer. If you find it for Cr2 plus, Cr2 plus means chromium electronic configuration is what? 4s1 3d5. 4s1 3d5. 2 electrons lost. 2 electrons it lost means what is that? 1 electron from 4s1 and 1 electron from 3d5. So how many electrons will be there here? In this case, it will be what? 3d4. 3d4 means what is the spin only magnetic moment? So 4 into 4 plus 2 means 6 4s are 24. That means root over of 24. Root over of 24 means, which is the 24 is the closest values to what? 25. So 25 root over is 5. So it is, we are going to get 4.8 something, which is the value is most close to 5. So it is what going to happen. So we are going to get the value which is more closer to 5, that is 4.8 something. So it is not the answer. So if you take Mn2 plus, in the case of Mn2 plus, so again Mn atomic number is 25. So its outer electronic configuration is 4s2 3d5. That means 2 electrons lost from 4s. So what is its electronic configuration? Outer 3d5. How many unpaired electrons? 5. So 5 into 5 plus 2. That means it is what? 7 5s are 35. 35 means whose value is more close to 6. So it is also, we are going to get 5.7 or 5.8. So this is also not our answer. What is the answer here? The vanadium, for which number of unpaired electrons? 3. So 3 into 3 plus 2, 5. So 5 3s are 15. So this is the answer. So next we are going to see the hydrogen, sixth question. Here hydrogen bonding order they are asking. They have given for liquid water, and they have given ice, and they have given impure water. Among them we have to arrange them in the order that who is having more hydrogen bonding order. Are you getting my point? Who is having more strong hydrogen bonding? So from this itself we can see that since because of hydrogen, strong hydrogen bond, the water turned into ice. The water turned into ice. So who is going to have strong hydrogen bonding? So ice will have strong hydrogen bonding. Then next what you are going to see, there is a confusion between liquid water and impure water. Since impure water contains impurities, there is not necessary that these impurities with the water they may form hydrogen bond. Hope you are getting my point. So these impurities will not form hydrogen bond with water. That's why who will form hydrogen bond? So between the water molecules there exists hydrogen bond. So next hydrogen bonding order will be more for what is that? Liquid water. Then who will have least one will be impure water, because impurities won't form hydrogen bond with the water. So who is going to form the strong hydrogen bond? Where it will be? It will be for ice. So here ice, because strong, because it is in solid state. Why it is in solid state? Because of strong hydrogen bonding interaction. So then it will come liquid water. As we know, liquid water will form what is that? Hydrogen bond among the water molecules. Hope you're getting my point. So this is what the answer order. So this is the last question of this inorganic chemistry for this shift. So here it is given from metallurgy. So since the question is came from metallurgy, here we have to select it from this column 1 and column 2. Here very important point we have to see, directly we can get it. in the option, so without analyzing, only one option if you could able to analyze, so we can get the answer. How? So if you see the electrolysis, so electrolysis is the process used to extract the highly reactive metals. Hope you're getting my point. Which metal? Highly reactive metals. So which one is the highly reactive metal among them? So what is that? Aluminum is the highly reactive metal. So to extract, for the extraction of highly reactive metals, generally we use, what is that process? Electrolysis process. So direct answer will be from B to A. That means from the following answer, following options we can get the answer. But here we will see on the explanation, John refining. What is that? John refining is the purification of metal technique. What is that? Purification of metal. Purification of metals. So what kind of metals we can see here? In the purification of metals, we can see silicon, germanium and gallium. So these are the metals which can be purified through which process? John refining. So since out of which silicon, germanium and gallium, so what is the option here is there? Silicon. So what we can write? John refining is a technique to use to impure, that means to purify the impure metal, to purify the impure metal. That is which metal here? Silicon. So silicon, germanium and gallium. So which metal is there here? Silicon. So this is the option. And in the case of next we can see in the case of blast furnace. So this is a blast furnace is a pyrochemical process where a lot of heat energy is given so that all the ore and fuel, everything is mixed together. So for what? So to convert iron ore into pig iron. What is that? The iron ore has to be converted into pig iron. So this pig iron will be utilized for making of what? Steel industry. Hope you're getting my point. So blast furnace, which iron will be helps to produce pig iron from iron ore. So this is what the option. And next we are going to see reverberatory furnace. So last option which is available is what? Copper. So in the reverberatory furnace, so what we are going to get? We are going to use the extraction of metals like copper. What is the process? Extraction of metals like copper, like aluminium, like nickel, so etc. These kinds of metals will be extracted in reverberatory furnace. So what is the difference between blast furnace and reverberatory furnace? In the blast furnace, ore, fuel and everything is mixed at the same point. So but in the case of reverberatory furnace, the ore and the fuel is kept away from each other, but only the fumes are going to touch the ore. So this is the only difference. Hope you're getting my point. So all the best for all the students, so for the next shifts. So and tomorrow again we will meet with another shifts discussion for especially inorganic chemistry, and all the best all of you. Thank you.